This is the first of a two-part series on initialization in Swift. In this video, we'll be looking at designated initializers for classes and structs, including Memberwise initializers, and we'll create multiple designated initializers for our objects. If this is something you want to learn, then keep watching. Initialization is the process of preparing an instance of a class or struct or enumeration for use. This process involves setting up an initial value for each stored property on that instance and performing any other setup or initialization that's required before the new instance is ready for use. You can follow along with me by downloading this starter project. A link is in the notes below. We will work with a single object and see how we can use designated initializers to create new instances. Let's start by looking at this class. I've commented it out because I want to copy it and use it in different places. Let's copy and paste it into line 20. And what's wrong with this class definition? Why do we get class person has no initializers? The reason is that when we create an instance of a class, no property can be left in an undetermined state. In this example, we have two properties that are undetermined, name and age. Dog is optional and defaults to nil, and nationality has been assigned the value of Canadian, so we have to look after those first two properties. There are a couple of ways to fix this problem. We can assign a default value to those undetermined stored properties. Doing this removes the error. Let me create an instance of person and run my playground. And rather than using print statements to check out the assigned properties of this instance, I'm going to click on this Show Results icon on the right. This presents the object inline here for me to check out. So from now on, if you see this pop up, you'll know that this is what I've done. I've run my playground and clicked on the Show Results button. This will save me from zooming out and back in again to show you the detail. Tapping it again dismisses the pop-up. Dog is optional, so if I want to assign a value, I can do it now after the instance has been created. This is quite limiting, so what we can do is create an initializer for those properties that do not have a default value or which are optional. So let's copy this original class once more and investigate this. Make sure you alter the name of the class to avoid conflict. So what is an initializer? Well, think of it as a function that is run whenever you create a new instance of an object. Its primary role is to ensure that all stored properties will be assigned a value when the instance is created. A function called init would look like this. We don't, however, have to use the keyword func, so we remove it. The parameters are all of those stored properties that need to have a value, so we will need to do something for name and age. It's standard convention to use arguments that are the same name as the properties, though that's not required. In fact, it can sometimes lead to confusion, so let's not do that at first, and let's use default name and default age and assign those parameter values to the properties upon initialization. When we create an instance of person2, we can think of it as calling that init function, only we use the class name as the function name, and as with a function, the init's arguments must always be provided in the same order as the init's parameter list. Now, as I said, the convention is for the init parameters to use the same label as the class property names. So let's change those. The trouble is that now we need to assign the name to name and age to age. So to distinguish between the two, we refer to the property itself using self. Let's take this initializer a little farther. Since it's basically a function, we can do other function type things within it. Let's copy person2 and paste it into this section and rename it person3. In a function, we can change or bypass the argument labels like this. Let's use default name again for name and underscore for age. This means that when we initialize our class, we need to use default name as our name argument label and leave the age argument label out completely, like this. Also, we can do other things within this initializer. We can write to a log, for example, or just print out every time an instance is created. Let's run this once more and notice the console displays the print statement each time you create a new instance. Let's go back to person 2 and copy it and paste it into line 67 and change the name. I'm going to create a new static class integer variable and set its initial value to 0. And each time we create a new instance, we want to increment this static value. If you don't understand static properties, I suggest you watch my video on instance and static methods because I go over static properties in that video, and I'll leave a link in the notes below. In our initializer, we can simply set self with a capital letter dot total to increment by 1. Self with a capital S refers to the actual type person4 and not the instance itself. This would be the same as typing person4 dot total plus equals 1. So let's create a new instance of this person4. To see what the total is, we just need to ask for person4, the class name, dot total. I'll also comment out the two previous person3 instances so I don't get confused with the print statements. Running this, I see that the total is 1. If I create a new instance and run, the total is now 2. Whether your property is optional or not, sometimes we want to be able to have a default value that will cover the majority of our type instances. What if the majority of our people were Canadian, but occasionally there was another nationality? Rather than making the property always Canadian, we can remove the assignment and add it to our initializer. Let's just paste that person2 class in here once more and change it to person5. I'll also remove the assignment of Canadian here and make sure I specify the nationality as a string. Now in my initializer, I'll add a nationality parameter and assign it the default value here. Of course, now that I have an additional parameter, I have to assign that value to the class property of the same name in the body of our function or our initializer. Now, when we create an instance of this person, we see that we have the option of picking from 2 different initializers. Let's pick the first one that does not include the nationality argument for the first, and another one using the second choice. The first one defaults to Canadian, and the second one is assigned American as expected. We could do the same for our optional dog property. What if, in our community, the majority of our people had poodles? Well, we could either assign it here, or we can use the initializer. So let's add an optional dog string parameter to our initializer, and like the nationality, assign it to the class property. In any case, the assignment to the optional happens on instance creation, but you can still set it to denote after the fact because it's optional. If I create a new instance now, I see that I still have 2 options for our instance completion. The first one, which is the same as this one, will give me the poodle and the Canadian nationality by default, while the second one will require all 4 properties, and I can override the initialized value of poodle and the nationality of Canadian. Let's check them out. I had 2 initializers presented, but I've got 3 different options for creating an instance. In fact, there's a 4th one. What if I wanted to default to Canadian, but allow me to override the default poodle assignment? We can simply do that by removing the nationality parameter. Well, all is good, but super confusing. Wouldn't it be nice if we had 4 initializer options presented to me instead of 2, so I didn't have to guess what to do? Well, hang in there. We'll get to that a little later. Before we move on, I want to show you something in an Xcode project that you can't do in a playground. Let me create a new Swift project. I'm just going to give it any name and save it to my desktop and delete it later. It doesn't matter if I choose Swift UI or UIKit. I'm going to copy our original example and paste it into the class of the first file I have showing in my Xcode project. Of course, I get the initializer error. However, I can right-click on the class name and choose Refactor, Generate Memberwise Initializer. This will create an init that will allow me to initialize all unstored properties. The only difference is that it also creates one for the optional dog, so we'd have to include that argument when we are creating our instance. What this does is allow us to initialize our person and provide a value for dog when we create our instance. If we wanted it to be nil, we'd have to specify nil. Of course, we could remove it if we wanted and our initializer will still work. It just means that when we create a new instance, dog will always be nil and we'll have to change it at a later date. Before we take a look at multiple initializers, let's look at structs. I've taken 2 of the classes that we had in the previous playground and changed the class designation to struct. Notice that I don't have any initializers for either of these structs, yet I'm getting no errors telling me that I'm missing initializers. In fact, if I start to try and create a new instance of person, we see we actually have 2 different options. One, like our class, presents only the names and age arguments, while the other presents all 4. Yet we haven't created an initializer. What gives with that? Let me create 2 instances. This is kind of like what we had with our last class example in the playground previously. Except with classes, I had to create an initializer to ensure that all stored properties had a value. Structs have something called a Memberwise initializer, which enables us to easily create a new instance of a given type without requiring any custom logic. What's new in Swift 5.1 is that we are no longer required to pass values for the properties that are optional or have a default value when creating a new instance. Previous to Swift 5.1, we would have been required to always use the longer form or resort to creating our own initializers. What's worth noting is that the Memberwise initializers are only available internally within the module that each given struct is defined in. If you've seen my video on Swift Package Manager, you'll know what I mean. Also, in previous videos, I've created sample classes and structs and placed them within the sources folder of the playground. In both cases, I had to make the struct and properties public so that I could access them in the playground file. The compiler treats the sources folder as a separate module. If I want to leave the dog as nil, yet specify a different nationality than Canadian, I can remove the dog parameter completely since it's optional and does not need to be initialized. Even though the structs have these convenient Memberwise initializers already defined for us, it's not to say that we could not create our own initializers that would override the Memberwise one. Our second example here is not crying out for an initializer, yet our static variable will always be 0 when we create a new instance. Let's confirm that. Yes, the total is 0. You might say, well, you could always create an external function that would set the value, something like this. But I'd have to do that every time I create a new instance. We can create an initializer, but if I just try to set one value in my initializer, I get an error when I create the instance. If I comment it out, I see the real problem. Return from initializer without initializing all stored properties. You see, you can't have it both ways. As soon as you introduce an initializer to a struct, the free Memberwise one becomes null and void. So we have to have, at the very minimum, added parameters for name and age, just like we had to do for the class. But we'll also add our self.total plus equals 1 so that we can increase or increment the static property. Once we do that, the error goes away. And our static property is increased when we create a new instance. Finally, we're at our last section. As I pointed out back in the class Designated Initializer section, I'd like to have 4 different choices for creating a new person. I'm going to start with this familiar person here, and this time there are no defaults and 1 optional. Let's copy the class and start to give it some initializers because, as you see, we get errors. There are 3 properties that we have to take care of. Dog is optional, so it's going to default to nil. Our initializer then needs 3 arguments, 1 for each of those properties. And in the body of our init, we assign those parameter values to the person properties of the same name. If we were to create an instance here, you'd see the single completion is available to me. Let's not do this now and carry on, but as I'm going to be creating additional initializers, let me comment this one first. I don't particularly like this initializer because if I want to be able to assign a dog, I can't do that at the time of creation. I'll have to do it after the fact. So let's add in that 4th parameter to include the optional dog. Now, when starting to create a new instance, we have 2 options to choose from. One that requires all 4, including the dog, and the other one that was our original one. If the majority of our persons are Canadian without a dog, we can create a 3rd initializer for that. Because the dog will be optional, we can leave it out of our parameter list, but we need to make sure that the value of Canadian is assigned in the body of our initializer. This now gives us 3 options to choose from when we want to add a new person. And finally, what if we wanted to have an option that defaults to the nationality of Canadian, but allows us to add a dog on creation? This will require 3 parameters as well. 1 for name, 1 for age, and 1 for dog. In the initializer body, we can set the nationality to default to Canadian. Now we have 4 options to pick from. But now for the cherry on top. If I'm creating a new instance of person from some file, and I don't really know what the background class initializers are, I don't really know what each of these 4 initializers will do. Well, all you have to do is add an extra / to your comment before the init. What this will do is add a QuickHelp summary comment to the init definition. Well, so what, you say? Well, let's try to create that instance now. Notice how that QuickHelp summary is shown at the bottom of our auto-completion dropdown? Helpful? I would think so. In fact, you should get used to adding QuickHelp to your class and function definitions, especially if you're working with others. If you're interested in that, please check out my video on that topic. I'll leave a link in the notes below. I'll be returning to initializers in part 2 of this series, and we'll dive deeper into them by taking a look at the convenience, required, optional, and fallible initializers. In the meantime, what you've learned here will cover you for most of your needs. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.